So now we will discuss the summary for Chapter 5. Chapter 5, MAC Sublayer. So the Ethernet MAC sublayer has two primary responsibilities. First is the data encapsulation and next is the media access control. So for the data encapsulation, the data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of a frame. In forming the frame, the MAC layer adds a header and trailer to the network layer PDU. So data encapsulation provides three primary functions. First is frame delimiting. The framing process provides important delimiters that are used to identify a group of bits that make up a frame. This delimiting this delimiting bits provide synchronization between the transmitting and receiving nodes. So for addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. Next is error detection. Each frame contains a trailer used to detect any errors in transmissions. The use of frames aids in the transmission of bits as they are placed on the media and in the grouping of bits at the receiving node. So for the media access control, the second responsibility of the MAC sublayer is media access control. Media access control is responsible for the placement of frames on the media and the removal of frames from the media. As its name implies, it controls access to the media. This sublayer communicates directly with the physical layer. The underlying logical topology of Ethernet is a multi-access bus. Therefore, all nodes or all devices on a single network segment share the medium. Ethernet is a contention-based method of networking. A contention-based method means that any device can try to transmit data across the shared medium whenever it has data to send. The carrier sends multiple access or collision detection or the CSMA or CD process is used in half-duplex Ethernet LANs to detect and resolve collisions. Today's Ethernet LANs use full duplex switches, which allow multiple devices to send and receive simultaneously with no collision. So, Ethernet evolution. Since the creation of Ethernet in 1973, standards have evolved for specifying faster and more flexible versions of the technology. This ability for Ethernet to improve over time is one of the main reasons it has become so popular. Early versions of Ethernet were relatively slow at 10 Mbps. The latest versions of Ethernet operate at 10 gigabits per second and faster. Scroll through the timeline to view the at the data link layer, the frame structure is nearly identical for all speeds of Ethernet. The Ethernet frame structure adds header and trailers around the layer 3 PDU to encapsulate the message being sent. Ethernet 2 is the Ethernet frame format used in TCP or IP networks. So now we are done for the summary of chapter 5 and I hope you learn a lot from me and thank you.